All right, it's going to start getting really good here. I just finished putting together all of the topics that I wanted to discuss, and they're not going to fit. I totally know that. We're going to move on to part three, maybe even part four, depending on what we've got. But this is just, I really wanted to go practical on you with BGP to say, okay, here's what we want, here's how to do it, and just kind of show you one thing after another. And I just started building a list. I literally have this big notepad file list over here. I can show it to you, just with all kinds of cool stuff that I was like, oh, I want to show this and that, and I eventually had to draw the line and say, okay, we've got to cover some more concepts before we go this far, but I've got a lot of stuff to cover with you before then. So I'm going to pick up right where the last nugget left off, which was right about here. We had just built a connection to ISP1. So that was kind of the pinnacle of the last nugget. I showed adding the neighbor with the remote AS command. We got this guy up and running. We added a description to him. Talked about shutdown. Got into the show IP BGP summary. In fact, let me bring that back in. Review that a little bit. Bring router 1 into the picture here. So, assuming all is still good, let me do a show IP BGP summary. There it is. Good. We still have that one neighbor, 151.1.1, and that's ISP1. The big thing that we said we wanted to see is the state / prefix received and never have a word here. If it's anything like idle or active or anything other than a number, something is usually wrong. So we want to see the number of prefixes that are received, and that's around where we left off in the last nugget. So where I want to pick up here is just actually starting off with another show command. I'm going to do a show IP BGP. Now, show IP BGP summary, I told you, was the MVP command of BGP. Huge for troubleshooting, primarily because of the neighbor report that it's going to give you. Show IP BGP shows the BGP topology table. Let me explain that for a second. When BGP receives routes, this guy's going to receive let's say the whole internet routing table from ISP1. He's also going to receive the whole internet routing table from ISP2. And before he puts them into a routing table, it kind of, if you want to talk about three tables, we've got the neighbor table, we've got the topology table, and we have the routing table. It's kind of the order of events. Forms neighbors, pulls the routes from those neighbors, puts them in this big topology table, picks the best of those routes, and then throws them into the routing table. And that's what the router uses for routing. So we've seen the neighbor table. That's our show IP BGP summary. Show IP BGP will give us the topology table and expect it to be huge when you get to the real world. It's going to be big because you're going to see the entire internet routing table. As a matter of fact, hang on one second. Have you heard of a BGP looking glass? Let me show it to you. A BGP looking glass is somebody who has made their router available on the internet for you to do show IP BGP commands and actually see the internet routing table. I'm just going to go to Google. I've got it over here on the side and type in BGP looking glass, and I put telnet because I want to be able to telnet to one. The most common place people go is right here. Which is cool because they give you a whole ton of options. You know, they show all these different servers. I could go to, well, Hong Kong, Japan, Netherlands. Hey, there's my hometown, Romania, Chara. It's a Romanian name. So, I could click on this, and for instance, this looks like this group gives us the ability to do pings and trace routes. The reason these are here, by the way, is because it's very useful when you start using BGP and advertising your own networks, like. Let's say I start advertising the 200 network to the world, 200.110. I want to see when it shows up in Romania. I want to see what path the Romania people are taking to get to my network so I can try and manipulate and see if I can get them to take a better path. And I'll talk about doing that later on. It gets really cool. But the problem with that first site, and the most common site, is most of them are these web interfaces where it's like, okay, you can do this or that. They don't let you do a real show IP BGP. Like if you try to just submit like a blank one, they're like, we'll resolve it for, this is for instance my IP address. They're like, we'll resolve it for your network. Look, we see this network in our table. It kind of gives us the information. But if you actually go back, hang on, let me close this. And go to, here's one of them. I just clicked on this Network World article from the field, and I was looking here. He was like, oh, this is an explanation of what a BGP looking glass is. But right there, it gave the host name for a server, route-server.ip.att.net. So let me actually bring that up. do a little quick connect. Let's go telnet route-server.ip.att.net. Is that it? Okay, there we go. So we're actually telnetted here to AT&T's route service monitor, and they're saying, hey, we've got these peers set up. Notice there's eBGP peers with all of these different routers that it's receiving routes from. It says, hey, you can log in with this username rviews and no password required. Now check this out. I'm going to do a show IP BGP. This is a real internet router. Actually, I'm really curious. Show version. Oh, denied. I wanted to see what kind of router it was, but it looks like they're locking it down to what commands we can do. I'm going to do a show IP BGP, and look at this. This is the one network. Let's start with one, and you can see the /22, and it shows we've got this network has all of these. This is one network, right? 10.1. Or not even, why am I saying 10? 1.0.4.0/22. And then look at this. It's saying I can get to that network through this guy, this guy, this guy, this guy, this guy, all the way down. Oh, and here's the next network, 1.0.16/23. And I mean, check this out. I could hold down the spacebar. Matter of fact, I will, which will probably cause a lot of processor load on whatever router that is. I'm just letting it go. Just going. And this is the one network. Now that's I didn't. Yeah. So going down this list, now I want my nice output back that wasn't wrapping around. There we go. So we've got 1.68 that I'm scrolling through. So a couple things while I'm here. Well, let me take this one because I've got a full output right here. Notice that we've got 1.72.0.0. It's saying I can reach that network on the internet through this next hop. I have a redundant next hop. I have a redundant next hop. I have a redundant next hop. All this. You see all these little stars? That means that is a valid route, meaning I know how to get to that next hop. Because there's times, and we'll see them throughout this series, there's times where you might get a route in the routing table from a peer, but you don't know how to reach its next hop. So it'll say, I know about it, but the star won't be there because it's not a valid route. Now come across here, you can see, we've got the metric of that route, the local preference. We're going to talk about all this stuff, the weight. But one I want to talk about right now is the path. This is that AS path. You might remember from kind of the foundations a couple nuggets ago, I talked about this. This is the little passport, meaning this route, this network 1.72.0.0 originated internally from somebody's network, and that was probably Autonomous System 9605. They passed it to 2904. They passed it to 7018, and there it is. And that's, by the way, most of the time why you see all this wrapping is the AS path gets so long. You can see right there it originated in I. It went to 4760. It just keeps going and then wraps around over here. Now, whoa, wait a sec. See that? 4760, 4760, 4760. What's up with that? And then 4760. It's what started. What's going on? What that is a feature called AS Path Prepending. It's trying to make a route not look as good. And we'll talk a lot about this. It's just a view of the table. I just wanted to give you a big picture view and then show you one more thing while we're on this BGP looking glass. That one. That little caret right there says, okay, I had all of these paths. That one's the best. You might be saying, well, why did you choose that one? 'Cause we're going to talk about it. But for now, I just wanted to give you that view of, that's a BGP looking glass. And look, I stopped the output. But that's just the one network that we scrolled through 50 pages of. That's going to be your routing table. I wonder if they let you do a show IP route. Oh, look at that. It's typing slow now. I probably bogged it down. Yeah. So look at this. Imagine having a routing table like this. Yeah. It's big. So anyway, enough drooling at this BGP looking glass. You can, check it out. Go for it yourself. It's fun. Well, fun for me. So looking at our little, it kind of puts this in perspective. We're like, lame. Where's the networks? But this is our little ISP scenario right here. We've peered with one ISP, and that happens to be ISP 1 over here on the left-hand side. Now we're going to bring up a peer, and I should mention it received all these routes. Notice when I look at the AS path, it said it originated from I don't know where. Not too sure. And then it went through autonomous system or left autonomous system 111. So that is probably the person that originated those routes. So now let me bring up the peer to ISP2. They are going to be 150.115 in autonomous system 222. I got to stop trying to draw with my mouse. 222. There we go. So a little review here. I'm going to go into global config mode. Let's do router BGP 500. That's our autonomous system. I'm going to do neighbor 150.1.1.5 remote AS, and I will say the autonomous system is going to be 222. Enter. Let me do a show IP BGP summary. Let's see if I can beat it there. So we've got idle. Notice it shows, oh, went from idle to active. Okay, active, so it's trying to actively form. Oh, I left the debug on. Look at that. So we went from passive, we went from active, from idle to connect. So active is saying, okay, I'm looking at the routing table. I'm trying to find a path to them. Went through, and I actually did this in the last one. Exchanged its capabilities, sent the open message, moved from open to open confirm, and then established we see the neighbor has gone up. Now when I do that same show command and I see, oh, I received 6 prefixes from him as well. Now here's what I want to show you. Let's get back to the show IP BGP. This is my secondary MVP command because it shows that whole routing table. And by the way, you can imagine there's a lot of filtering options on that. I mean, all of these, those are just ways to filter that output because as you just saw, it gets quite enormous from the internet-based router. So I do my show IP BGP. I see all of the routes that I've received. Now I started adding in a couple secondary routes because I wanted to show this to you. We've got 153.1.1.0 and 153.2.2.0. And what I said was these are part of some other autonomous system over here on the left-hand side. That's where those came from. So I wanted to have some routes that didn't originate just from this and just from this. So this guy could have some competing choices. So we look at this and we go, okay. We've got 153.110. You following? We've got, I received it from ISP2. There's our 2222. I received it from ISP1. He chose the best one to be ISP1. And same thing down here. I see I received this network from ISP2, ISP1. He chose the best to be ISP1. So I can guarantee you if I go and do a show IP route, that's going to be the route that's in the routing table. So I look for 153 right there at the top, and you can see it's using the next hop of that ISP1. That was the best one that was chosen. So now let's talk about this. Why did it choose that route to be the best? Well, that comes into the world of the BGP metric. And you can't even call it a metric because it's just a big bleh. Cisco calls it a route selection criteria, but it really is just, well, let's look at it together. There it is. Bleh. The BGP path selection process. So here's how BGP picks the route. So it received all of these routes, or you could pull up that AT&T router again and say, show me all that. It received all of these millions or hundreds of thousands of routes, but actually into the millions for that AT&T router because of all the peers. How did it pick the best? Well, what it does is it receives the route. Let's just grab one of them. 153.1.1.0. That was one of the ones that I'm looking at on the right there. So I've got this route. First thing it's going to do is I received it from multiple sources. Let me see. Which one has the largest weight? Does one have a weight higher than another? Matter of fact, let me just bring this back over here. That show IP BGP. You notice right here, when I did this, one of the columns was the weight. And every single one of them was 0, all the way down. So it says, okay, well, looks like that's tied. Let's move on. Let's check the local preference. Does anyone have a higher local preference than the other? Again, coming back to this table, look over there to the left. There's a column, local preference. It's all blank, 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 blank. It's not 0 because there's actually a different default. I'm going to tell you that in a little while. But it's going to go through. So what it's going to do is go through this list and pick based on, whichever one breaks the tie first, breaks the tie. And I mean, I tried to word these in as plain of, I mean, if you type in, go to Google, type in BGP path selection process, you'll see this same list, but it'll be in a lot more techie language from Cisco. I tried to word it as straight up as I could. So it's going to prefer highest weight, local preference. We don't know what those are yet. That's okay. It says, I'm going to prefer locally originated routes, meaning routes that I generated. So for instance, if router 1 came up with any of these routes, like it's like, oh, I made that one. It's going to say, well, that's what I prefer. Then, now notice the next one down in the list. This one's huge. Shortest AS path. That is probably the strongest manipulation that you have on choosing the best path. It's a very strong attribute. I mean, if you look, you have weight, you have local preference. What are they? They are administratively set, administratively controlled by you. So if you didn't set the weight, if you didn't set the local preference, then they're always going to be blank. They're always going to be 0, and this little blank for the local preference. They're always going to be that way. So, the next one is routes the router originated, which there's not going to be that many of those. So this right here, this AS path, is extremely, people call it a strong attribute. It is one of the biggest influencing attributes of why BGP will choose the best path. And that goes back to the very beginning of this whole series when I said BGP, by default, will pick the best path based on autonomous system hops, where it says, okay, 1 hop, 2 hop, I'm there. Okay, I reached it. That's the best path. And so that's one of the strongest ones that we can originate. But you can go, it says, okay, well, if that one's tied, let's go to the origin type. It says, well, let's look at where this route came from. Internal routes are a little more favorable than external routes, are a little more favorable than question mark. And again, at this point, I'm showing you this list, but I'm kind of like, just kind of take this with a grain of salt right now, because I'm really like, it's like, this is nugget 5, nugget 6, nugget 7, nugget. I mean, we're going to go through and break down each one of these, and there's a full explanation of when and why and how. And you'll eventually see that there shouldn't be anything that has an E route. And there's nothing that originates using EGP. But you notice all of our routes came in with an incomplete. It doesn't know where they came from. That's where that comes in from. So it's saying, I'm not too sure where that came from. It is considered incomplete. So that is less preferred than E. That is less preferred than I. And it goes down in this list. Let me just hop through. Okay, blah, 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 blah. Right here, we come to a big kind of bracket that I put in, maximum paths check. Here's what that means. BGP, by default, will load balance nothing. So if I have, for instance, ISP1 and ISP2, and I receive the same routes from them, and everything's tied. It's like tie. It's all, they're totally equal. BGP will say, no, I must pick the best. I will not choose one, I will not choose both and load balance over them. I must pick one. Now that is a setting. That is its default setting, is saying, no, I must pick the best. So if maximum paths, it's actually a configuration command, is set to 1, that means I will only allow one path in my routing table. So if one path is allowed, now it's going to go for some surefire tiebreakers. It's going to say, okay, chances are one of these routes was learned before the other. I'm going to pick the older route. And that will 99% of the time break the tie. But you know what? If it just so happens, the moon's aligned, whoa, coyote howled, oh, something was like, okay, the same millisecond those routes came in, it's going to say, all right, I'm just going to pick whoever gave me the route, whoever had the lower router ID, they're the winner. Let's go, Alex, I choose that one. And so it's going to put that one in the routing table. Now, if you choose and you say, well, let's do a little load balancing action. I'm going to set the maximum paths to 2. Then at that point, if the routes are tied all the way down, they reach this point, it goes, okay, all things considered, I would say those routes are pretty well equal. Use them both. And that's where you put them both in the routing table. It won't actually use these last two because those are surefire ways to break any tie. You're going to see that slide again and again and again and again and again and again. It's going to be one of those things. I'll say if you're certification prepping, it's one of the things you'll want to commit to memory. And I'll show you kind of where the line, you don't have to memorize all of it, just most of it, where the line is drawn on that. So last thing I want to show you here, before I kind of put a dividing line and then get into another topic in the next nugget, is just how we can start influencing things. How to start modifying things and making decisions. Let's just start really simple. I'm going to start with that major attribute. It was attribute number 1. Who remembers what it was? It's like one of those memory tests. What was the number 1 way BGP uses to pick routes? Wait. The ones with the highest weight. And wouldn't you know it, that's a Cisco proprietary attribute. Just like Cisco to make theirs the like #1 tiebreaker, right? But it's actually not that bad. The weight is probably the simplest, easiest attribute that you can use, and it's okay that it's proprietary because the router never tells anyone what its weights are. It's not something that's like, for instance, normally when you're like proprietary, you're like, okay, router 1 and router 2, they got to be Cisco. ISPs, they got to be Cisco routers too because you're using the weight, and every route that you're sending is going to be tagged with this little proprietary weight flag, and nobody else support. Nope. That's not how it works. The way the weight works is it's all local to the router. When I set a weight on router 1, it will influence router 1 in a major way, in a heavy way. That's a good way to remember it. In a heavy way, but it's not going to be told to anybody else. Router 1 will just pick the best routes based on that. Let me show you. I'm going to do just in this nugget because this is kind of like our intro into BGP and peering. I'm just going to do a very simple way of setting the weights. We saw, let me bring this back in here. We saw when I did a show IP BGP that router 1 was preferring this guy to reach. Now again, let's look at this table. It's saying I have 2 paths to the 153.110. I can get there through this one, which is ISP2, or I can get there through ISP1. That's this little blank gap right here. But it says I chose ISP1 as the best. That's why this little caret is right here, because he's the best. And now, looking at that little table, we can say, well, I know why that is. It's because it worked its way down through the list, and this guy happened to be the oldest route. It was the one that was learned about first, or it was the one with the lower router ID. I'm not too sure which one broke the tie. I would, chances are oldest route since we just set this guy up in this nugget. But that's why it chose it. But I might say, well, you know what? ISP2 is better. They're cheaper, they're faster, they're better. I want to prefer them and use ISP1 as a backup. Here's an easy way to do that. I'm going to do a show run section router BGP. If you haven't seen that section command before, oh, you are missing life in the Cisco world. I'm going to go into global config router BGP 500. And I'm going to tweak with this. I'm going to go in and say, okay, for the neighbor 150.1.1.5, right click on that. I'm going to say, you can see one of the options, a bunch of options that I could say, but I'm just going to say the weight, look at this, the default weight for routes from this neighbor, you know where I'm going now, the weight is going to be 5. That's it. I'm saying that guy's heavier than the other guys. Now, when I go back and do a show IP BGP, I know you're thinking, you're like, it's going to change? No, it's not. It's not broken. Don't worry. Anytime you change a filter, this is considered a filter or something in BGP, I have to clear the session. Now, let me show you. If you work for a service provider, it's your last day, you're like, I just want to go out with a bang. Here's how you do it. Bang! Run. Really quick. Grab your bag. Just run for the door. Alarms are going to go off. Things are going to sound. I mean, in a major ISP, like take AT&T, that router that we were just on with a BGP table. And it had, what was that? Just this silly. It was like 12 different BGP peers. It showed on that logon banner that for AT&T. Now I'm going to go back and look. If you were to do that command, that would tear down all 12 of them and completely flush every route. Now that's hundreds and thousands and millions of routes that just got flushed. Will BGP recover? Yes. Now, I mean, and you look right here, you're like, well, that wasn't too bad. That wasn't too long. Well, yeah, it's not too long because it's two tiny ISPs with very, very few routes that are actually coming from them. But when you're a size of that AT&T router, you not only have to restore all those neighbors, I would say that probably would happen in 1 to 2 minutes, but then you have to receive all of those routes from all of those neighbors, process through all of those routes from all of those neighbors. I mean, you could be looking at a 5 at the low side, 5 to maybe 10, 15, 20-minute outage, depending on the speed of the routers and the links and all that you could cause by doing that. Now you notice, you can see it, you saw before I did that clear, none of the weights had adjusted themselves, but now that I'd cleared it, the neighbors reestablished, it resent those routes. All of the routes from ISP2 are coming in flagged with this weight of 5, and you notice these little pointers, what have they done? have all dropped down, and they're now pointing to ISP2 as the favored one because it has a higher weight. So and now that was a broad sweeping change, which would change every single route. ISP2 will always be the preferred for every single route that it has a path to. So looking at that show IP route, all of those are now in the routing table as the best route to reach that conflicting network, the one that they both had a route to. So that's good stuff, definitely. I would say syntax-wise, we didn't see a ton of new syntax, new commands, and all that. But conceptually, I would just sit down right now and relax, have an ice cream cone, think about route selection process. Just kind of start churning that over in your mind, because conceptually, I think I just talked about some of the biggest concepts that we will cover in BGP, and we're going to be spending the rest of this series breaking each one of those down. For now, I hope this has been informative for you, and I'd like to thank you for viewing.